All right, hi folks, this is Larry Maslino. I'm recording a video for Objective 4 in ALEKS. So Objective 4 has a couple of parts to it. One is solving quadratic equations, and then we use that method to work with rectangles and what's called Pythagorean theorem. Let me start out with some examples of solving a quadratic equation. All right, so here's an example. And let me list out the steps on how to solve a quadratic equation. And what we're trying to do is find a value for x or v that if you plugged it back in the starting equation, you would end up with a true equation. Well, here are the steps to solve a quadratic equation. Step one is get the equation set equal to 0. So I need to have 0 on one side of the equation to begin with. In this example, the equation is set to 0, so I really don't need to do anything for step one. Step two is factor the one side of the equation. And you might remember we can break this up and factor it as two binomials. All right, well, I'm going to put a v and a v in front so that when I multiply these back, it gets me back to the v squared part. All right, now I'm noticing this constant in the back is a negative number. Anytime you have a negative number as the constant, you know the signs are going to be different. One sign is going to be plus, one sign is going to be minus. Now I need two numbers to multiply to negative 14, but then they have to add to negative 5. So let me try to figure out two numbers that add to negative 4, that multiply to negative 14, but add to negative 5. All right, well, some options are negative 1 and 14, positive 1 and negative 14, negative 2 and 7, and 2 and negative 7. So all of these numbers multiply to negative 14, but I need the option that adds to negative 5. I could see it's right here, this one. Those two numbers add to negative 5. So I'm going to make this v plus 2 and a v minus 7. And again, I could double check that my factoring was correct by remultiplying this back using FOIL and confirm I get back to the starting equation. All right, so we just did step 2. Step 3 now is set each factor. That really means set each parentheses separately equal to 0. So that means I'm going to take this first parenthesis, v plus 2, and set it equal to 0. And then I'm going to create a new equation and take the second parenthesis, v minus 7, set that equal to 0. Well, when I solve these two equations, I'll subtract 2 from both sides for this one. I get v equal negative 2. On this one, I'm going to add 7 to both sides. I get v equals 7. So notice there's two answers, two solutions to this problem. V equals negative 2 and v equals 7. I could check my answers by plugging these numbers back in the starting equation and confirming that I really get a true equation out of this. Let's do a quick example. I'm just going to check v equal negative 2. All right, so what I'm going to do is plug in negative 2 in place of v and see if I really end up with 0 as the answer here. All right, negative 2 squared, that's positive 4. This is going to be a negative 5 times a negative 2, that's plus 10. And you could see this is going to be 14. Subtract 14, that does equal 0. So that gives me confidence that v equal negative 2 was the correct solution here. I could do the same thing with v equals 7, and I would see that's also a valid solution. Okay, so these are the 4 steps. Step 1 is get the equation set equal to 0. Step 2 is factor one side. Step 3 is set each factor separately equal to 0. And step 4 is solve each one of these equations where you take each parenthesis and separately set it equal to 0. This is the step-by-step of how to solve a quadratic equation. Okay, you're going to need this method in Objective 4. All right, let's do a couple more examples here. Let me go to an example. that says solving an equation written in factored form. All right, well, for this problem, we're really going to do the same setup, but notice they've already factored this for us. So step 1, getting the equation set equal to 0, that's done. Step 2, factor the left side of the equation. That's done. So all I have to do now for this one is set each one of these parentheses separately equal to 0. Now, you could really think of this 3 in parentheses. So I could think about setting 3 equal to 0, but of course I'm not really going to bother doing that because I know that leads me to a false equation. There's no solution for that part, but I can set z minus 8 equals 0, and I can set negative z plus 6 equals 0. Now let me solve these equations separately. Here I'll add 8 to both sides. So that gets me z equals positive 8 on this one. On this one, I'm going to add z to both sides. That's going to cancel this out. I'm going to end up with z equals 6. So there's 2 solutions. Z equals 8 is one solution, and z equals 6 is the second solution. Okay, so this problem was actually a little easier than the problem we did a few minutes ago because they already factored the quadratic equation for us. Then all we had to do was set each parenthesis separately equal to 0. All right, why don't we go and try another example here. And I'm going to do this problem the same way. It's just that the factoring on this one is going to be a little different. All right, so let's do the steps that we talked about. By the way, I know this is a quadratic equation because anytime I see a x squared or a v squared, that tells me it's a quadratic equation. All right, step 1, get the equation set equal to 0. Get the equation set equal to 0. Okay, well, I'm going to add 28v to both sides of this equation. If I do that, I'm going to end up with 4v squared plus 28v equals 0. Step 2, factor the one side of the equation. All right, well, when I look at this left side, I'm noticing there is a GCF, greatest common factor. So I'm noticing the greatest common factor is 4v. So I'm going to pull that out in front. If I factor out of 4v, it looks like it's going to leave me with v plus 7 inside the parentheses. I can always check that I did this factoring of the greatest common factor correctly. I can think about remultiplying this 4v inside the parenthesis. And if I do that, it would show me that I would get back to the starting expression, so I know it's correct. All right, step 3 is set each factor separately equal to 0. Factor means the quantities being multiplied. All right, well, I can think of this 4v as one factor and the v plus 7 as a second. So I'm going to make 2 equations. 4v equals 0 and v plus 7 equals 0. The last step is just solve each one of these simpler equations. Well, I want to get v by itself, so I'm going to divide both sides by 4 here. That gets me v equals 0. And on this one, I'm going to subtract 7 from both sides. That gets me v equals negative 7. So again, I end up with 2 answers to this question. By the way, notice Alex says separate your answer with commas. So in the answer box, you would enter 0, 7. Negative 7, sorry, 0, negative 7. Again, if you wanted to check these answers, you could substitute these answers back in the starting equation and confirm that you get a valid equation as a result. All right, let's go ahead and look at a couple of equations. How about if we do one here, a word problem? All right, let's take a look at this one. It says the length of a rectangle is 4 feet less than 3 times the width, and the area of the rectangle is 55 square feet. Find the dimensions of the rectangle. Well, when they say find the dimensions, they're really asking me to find the length and the width. All right, well, let me start out by letting, let's say, W equal the width. I'm going to let W equal the width because I really don't know anything about the width. So whatever quantity I know the least information about, I'm going to let that equal a letter like W or X, or you can use whatever letter you want. Now, let me try to come up with an expression for the other unknown quantity, which is the length. All right, I need to come up with some expression for the length. Now, I'm going to use this first sentence. It says the length is 4 feet less than 3 times the width. All right, well, the length of the rectangle, the word is equals. So the length equals 3 times the width. Remember, we called the width W. So 3 times the width would be 3W. And when they say 4 feet less, they mean subtract 4 in the back here. So when you see 4 feet less than, it means subtract 4 from that quantity, right? If I said to you, calculate 4 less than your age, you would have to take your age, subtract 4. All right, so we just figured out the length is 3W minus 4. All right, let me go to this sentence that says the area is 55. All right, well, I need to know the formula for the area of a rectangle. The area of a rectangle is length times width. If you don't remember that formula, it's in the back of the reference packet. So the very back of the reference packet has a lot of formulas from geometry. All right, but let me plug in. For the length, we came up with that as 3W minus 4. For the width, we call that W. Now I need to solve this equation. All right, what I'm going to do to start with is let me take this W and multiply it inside the parenthesis using distributive law. Well, that's going to be 3W squared minus 4W equals 55. Well, now you might notice this is a quadratic equation. Remember, anytime the variable is raised to an exponent 2, it's a quadratic equation. So let's follow the steps that we talked about to solve a quadratic equation. The first step is to get the equation set equal to 0. So I'm going to subtract 55 from both sides, because that's going to get me a 0 on this one side. Okay, so that's step 1. Step 2 is factor. So let me try to factor this left side. All right, well, I know to get a 3W squared, I need to put a 3W in the front of one parenthesis and a W in the other, because I know if I multiply these back, it'll get me to 3W squared. All right, now, in the back of the parentheses, I need 2 numbers to multiply to negative 55. But when I do this multiplication, I need the middle term to be a negative 4. All right, so now I have to think about different combinations that I could put in these parentheses. Now remember, you could use the AC method, or you can use a trial and error method here. All right, well, maybe I'm going to try a trial and error method, because there are not that many numbers that can multiply to get me 55. So I know to get me to 55, I can either use 5 and 11, or I could use 1 and 55. All right, let me do trial and error. I'm going to try to use 5 and 11 in the back. So I'm going to try to use a 5 and 11 in the back and just see if this works. Now, what signs should I put in the parentheses here? Well, I know this constant back here is a negative. So these 2 numbers in the back of the parentheses have to multiply to get me negative 55. Well, the only way to get 2 numbers to multiply to get to be a negative is the 2 signs have to be different. So I'm going to put a plus and a minus here. All right, let me try and see if this worked. So I'm going to do a FOIL multiplication. All right, 3W times W is 3W squared. 3W times negative 11 is negative 33W. And then 5 times W is plus 5W. Negative 5 times negative 11 is negative 55. Well, this isn't going to work because I could see these middle terms are not going to get me the negative 4w that I need. So that didn't work. Let me try another option. Let me try putting the 11 in front and the 5 in the back. Let's see if this works. This is what I call a trial and error. You try one possibility. If it doesn't work, you go back and try another. All right, so let's multiply this out. 3w times w is 3w squared. 3w times negative 5 is negative 15w. 11 times w is plus 11w. And 11 times negative 55 is minus 55. Does this work? It looks like it does work because notice these two middle terms get me negative 4w in the middle. So this is the factoring that I want. Okay, so let me write this up here. Let me erase this. So we came up with the factoring as 3w plus 11 times w minus 5 equals 0. Well, remember, the last step is to set each parenthesis separately equal to 0. So I'm going to do 3w plus 11 equals 0 and w minus 5 equals 0. All right, let's solve each one of these equations separately. I'm going to subtract 11. That's going to give me 3w equals negative 11. Then I would divide both sides by 3. I would get w equals negative 11 thirds. But I know I'm talking about the width of a rectangle. It doesn't make sense to have a negative width. So this answer doesn't make any sense. Let me come over here. I'm going to add 5 to both sides. That gets me w equals 5. So that's the answer I'm looking for. So we just figured out w is 5. But we also need to figure out the length. Well, the length is 3w minus 5. But now we know w is 5. So 3 times 5 minus 4. That's going to be 15 minus 4. That's going to get me 11. So the width of this rectangle is 5. The length is 11. All right, so I had to set up an equation on this, and it led me to a quadratic equation. Then I went and solved the quadratic equation. All right, folks, let me do one more example here. Let's come to this one. It says, use Pythagorean theorem. All right, well, for this one, I'm going to help you set this one up, but I'm going to let you try this one. First of all, what is Pythagorean theorem? Well, you have a right triangle. It's a triangle with a right angle like this. If you label the one leg A, the one leg B, and the one leg C, by the way, this length C we call the hypotenuse. It's the side opposite the right angle, and it's always the longest side. So this is the hypotenuse. The formula says that C squared equals A squared plus B squared. This is in the reference packet. It's an important formula from geometry. All right, let's go ahead and try to set up this equation. All right, it says the length of the longer leg of a right triangle is 19 feet more than 5 times the length of the shorter leg. So notice I really don't know much about the shorter leg. So how about if I let x equal the shorter leg, the length of the shorter leg? All right, let me try to come up with an expression for the length of the longer leg. Well, from the first sentence, it says 19 more than 5 times the length of the shorter leg. So I'm going to write that as 5x, that's 5 times the length of the shorter leg, plus 19. All right, let me go to the hypotenuse. They say the hypotenuse is 20 more than 5 times the length of the shorter leg. So I'm going to write that as 5x plus 20. All right, now I'm going to plug into Pythagorean theorem. In place of C, I'm going to put 5x plus 20. That quantity is squared. A is one leg. We call that x. B was the other leg. We call that 5x plus 19. All right, now this is going to be a little messy to solve, but let me give you a hint on how to get started. When I see 5x plus 20 squared, It means I have to take 5x plus 20 and multiply it times itself. Of course, for this, I'm going to do a FOIL multiplication. On the right-hand side, notice we have 5x plus 19 squared. Again, for that, I need to write this as 5x plus 19 times 5x plus 19. And again, for this, I'm going to have to work out a FOIL multiplication. Once you do these FOIL multiplications, you're going to end up with a little bit of a messy equation, but step one is going to be you're going to get the equation set equal to 0. Then you're going to factor the one side of the equation. Then you're going to set each factor separately equal to 0. All right, so I'm going to let you try this one. You can email me if you get stuck or if you need any help. But hopefully the setup is useful in getting started. All right. Thanks, folks. Please let me know if you have any questions working in Objective 4.